It's May 4th, guys. May the 4th be with you. Today is Star Wars Day. If you're watching this video on Monday, if you're watching it on another day, happy late Star Wars Day to you guys, or belated Star Wars Day. Hopefully you guys are just as excited as I am. Watch yourself some Star Wars today on Monday, May 4th. May the 4th be with you. All right, let's get started. We're going to start into our next section where we're going to determine whether triangles are similar based on the three different postulates that we have been studying. Okay. In the past 2 weeks, the assignments that I've been giving you have been asking you, hey, are these triangles similar based on this postulate? If they are, go ahead and give me the similar statements. Okay. This week, we're not going to be working with similar statements. We're going to be working just strictly with the postulates. You guys are going to be determining which postulates prove that these triangles are similar. Some triangles won't be similar in the assignment today, and we'll go through some examples of that. All right. So let's go ahead and get started. Let me bring up the assignment here. Okay. So what is being asked in this assignment, in this question for this week, it's asking, determine whether the triangles are similar. If similar, state how. Angle, angle, side, 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 or side, angle, side. If not, then we're going to, our answer choice is going to be that they're not similar. Okay, so that's what we're going to be doing. We're going to be picking one of these three. Again, not similar is also one of the answer choices. You're going to have multiple choice questions this week. All right, it won't be fill in the blank. And our job is simply just to figure out, are these similar? And if they are, which postulate proves that they're similar? Okay. The reason that I wrote these down here is so that we can do like a process of elimination. You're going to see we're going to really quickly figure out which postulate we're going to use, and then go ahead and go into actually proving if the postulate works, if it holds, okay, if the statement holds. Again, we're not going to be using similar statements this week for this assignment. We're simply just going to be picking one of these three postulates that proves that these two triangles are similar. That's all we're going to be doing, right? So let's go and take a look at our first example. Okay, so I have a small triangle here, we've got a bigger triangle here. We have two sides labeled here, two sides labeled here, and we have an angle labeled on each of these. All right, so looks like we have side angle side, side angle side. So more than likely we're going to be using this postulate. All right, we can't use angle angle because we only have one angle that's being shown to us that is similar or congruent. So more than likely it's not going to be angle angle. And side side side, we would need all three sides to be identified in order for us to test if side 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 is going to work. So we're going to go ahead and eliminate that one also. So you can see here quickly we can determine just by looking at the picture which one of the postulates we're going to attempt to use. Okay, more than likely the answer is side angle side, but we still have to make sure that that's the case, because remember there's still a fourth option. The fourth option is not similar. All right, so we have to prove to ourselves that these two are similar. Now this is really easy, especially using side angle side. First of all, the A is already given. The angles right here and right here, these two angles are congruent. Just by the simple fact that they've been labeled with one of those marks shows that these two angles are congruent. All right, so that's easy. We have the A. Okay, I'm going to go ahead and just put an arrow showing that the A has been proven already. Now we just have to prove the sides. Side, 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 side. Okay. Another important thing in a problem like this, and you're going to run into this type of situation in your assignment today, the angle that is being used to prove similarity on the triangles has to be in between the two sides that you're testing. All right. Notice in the statement itself, the A is in the middle, showing you that the angle is between the two sides. It's included, what we say in geometry. It's the included angle. Okay, so for example here, angle F is included between side EF and side GF. Okay, it's included, it's in the middle. It's almost like these lines are pointing to the included angle, angle F. Okay, same thing here. Angle T is included between side RT and side ST. Okay, these two sides kind of look like they're pointing to angle T. Therefore, angle T is included. Okay, if the angle that you're testing between the two triangles to prove similarity, if the angle is not in between the two sides that you're testing, you can't use this postulate. Okay, the angle has to be included. It has to be in between the two sides. In this case, it is included, right? It's here in the middle. Angle F's in the middle of these two sides, and angle T is in the middle of these two sides. So we can go ahead and proceed. All right. To check if these two triangles are similar based on the sides, we're going to be using proportionality. Okay. Basically, we're going to set up two fractions, and we're going to see if they're congruent to each other, if they're equal to each other. All right. So I'm going to make two fractions, and I'm going to see if they're equal to each other. Right. The numerator is going to be based off of the smaller triangle. The denominator is going to be based off of the bigger triangle. Okay, watch how I do this. I'm going to take the two sides and I'm going to go from least to greatest. All right, what's the least number on these two sides? Of course, it's going to be 3. So 3 is going to go first, and then 5 is going to go second. Okay, you have two numbers to determine which one's least and which one's greatest. That's very easy to do, right? The smaller number is least, the bigger number is the greatest number. I'm going to do the same thing here on the bigger triangle. Okay, between 9 and 15, which one is smaller? It's going to be the 9, so the 9 will go here. 15 is the bigger one. It's going to go here. Okay. Now, if you can't see right away that these two fractions are equivalent to each other, use your calculator. Okay. If you're not sure, use your calculator. So basically what I'm going to do, head over to my Inspire. I'm not going to use nsolve. Okay. nsolve is when we're looking for a variable, and you notice we don't have a variable here. We're just going to see if these two fractions are equal to each other. So I'm simply going to control division sign for my first fraction. My first fraction is 3 over 9. 3 over 9. Okay, and I'm going to see if that is equal to the second fraction, 5 over 15. Sorry about that. Okay. 5 over 15. Okay. If they're equivalent, when I hit enter, it's going to say true. If they're not equivalent, it's going to say false. Okay. We get a true statement. So we know for sure that the sides are proportional. Therefore, that makes these two triangles similar, and they're similar using the SAS similarity postulate. Okay, so that would be your answer. Let's say if you had a question like this on your assignment, you'll have 4 options. It'll be multiple choice this week. These will be the 3 options plus the not similar, which could be the 4th option, and we'll run into that here. Okay, let's move on to our next example. Notice again, I kind of just wrote out the 3 different postulates we could be using so that we can use process of elimination and really try to help narrow down how we're going to solve or prove if these two triangles are similar or not. Okay, so we have our 2 triangles here. All right, angle, angle. Well, we have 2 angles here. We have 1 angle here, but we know that 42 and this angle right here, since they're vertical angles, are the same. These 2 angles are going to be congruent to each other. So this one's 42, this one's 42. So that's a possibility. Okay, let's not cross that one out yet. SSS, we would need to know all 3 sides before we could use this postulate. We don't know any of the sides, so for sure it's not going to be SSS. SAS requires us to know at least one of the angles. Okay, we have 4 angles here, and 2 of the sides. Again, we don't have any of the sides, so SAS, you can cross that one out. More than likely, we're going to be working with angles. Angle, angle. Okay. In order for us to prove with angle, angle, we need to show that 2 of the angles on both of the triangles are congruent to each other. Currently, we have 1 so far, 42 and 42. We know for sure those are congruent, so we have one of the A's taken care of. We need to find the other A though, right? This one's 53, this one's 85. Those two aren't going to work. We don't know what angle E is. We don't know what angle D is. So what we can do is use what we know about properties of triangles. We know that any triangle, all the angles have to add up to 180 degrees. Okay, so let's go ahead and figure that out. If we have 53 and 42, we can subtract that from 180. Minus 53 minus 42. Okay, I'm going to go ahead and go through this fast. Use your calculator or use your head, however you want to solve this problem. You're going to see that that's going to come out to 85. Okay, so this is 85 right here. And we can kind of stop. Notice there's an 85 here and there's an 85 here. So we have one angle that are congruent, one pair of angles, sorry, and then we have our second pair of angles that are congruent. Okay, we can stop right there. We know, I don't even have to prove that this was 53. Just by knowing that these two are congruent and these two are congruent, we know that the 53 has to be congruent. There's no other option for this to work. So our answer is going to be angle-angle similarity. Okay. So try to go through this process as you're going through your assignments. First, determine which postulate more than likely am I going to use to prove congruency. Okay. Once you can eliminate the other two, work with that postulate and then see what you can come up with. All right. So hopefully that made sense to you guys. Angle similarity. Okay, notice I'm not asking you for any similar statements. We're just trying to pick out which postulate will prove that these two triangles are similar. All right, let's go and go on to our next example here. All right, so again, let's determine which postulate we're going to be using. All right, angle-angle. Okay, angle-angle requires that we know two of the angles off of each triangle that at least are congruent. Okay, we have congruency here and here because that's given to us. We have congruency here and here because that's given to us. More than likely it's going to be this postulate, but let's just double check the other ones. Side, side, side. We need to know all three sides of both triangles in order to prove this one. We don't know any of the sides, so side, side, side. We can kiss that one goodbye. Okay. Side, angle, side. We need to know at least one angle, which we do, and we need to know at least two of the sides, which we don't. Okay. Again, none of the sides have been labeled here with values, so more than likely it's not going to be this one. Okay. So let's look at angle, angle. And again, so long as we can prove that two of the angles are congruent, then we can prove that the two triangles are similar. So again, going back here, this angle and this angle, they are congruent with each other because of the markings. Okay, and angle J and angle K are also congruent to each other because of the markings. They have two hashtags on them, or two angle markings, I guess you could call them. All right, so if we have one angle and we have two angles, then we can safely assume that the third angle is going to be congruent, and we know that these two triangles are similar to each other. Based off of the definition of similarity, remember all angles between two similar triangles are congruent to each other. Okay, it's the sides that are proportional, but the angles are congruent. They're equal to each other. All right, pretty easy enough. So we had the first problem was side, angle, side. Second problem was angle, angle. Third problem was angle, angle. Okay, I've got two more examples to show you. Hopefully they'll cover the other examples here so that you get a little bit of all the different examples. All right. From there we'll go on to this example. It's our fourth example for the lecture for today. Okay, same thing. I just wrote down our three different possibilities so that I can do a process of elimination and then figure out which one more than likely am I going to use to try to figure out what's going on here. Okay. All right. Angle, angle. Always start there. We have one angle here, two angles, two angles. We don't know the third angle, but we can figure that out. This might be a possibility. Okay. Side, side, side. We don't know any of the lengths of the sides, so this one's not going to work for us. We have to know all three sides before we can prove similarity. Side angle side, we have at least one angle, which is the A, okay, but we don't have any of the sides. So more than likely it won't be that one either. So again, we're going to try to use angle, all right? So we know for sure angle Z and angle G are congruent because they're both 90 degrees. So we have one of the A's accounted for. Okay, we need to figure out the other A. 61 and 34, they're not congruent, so we can't use these two angles. We don't know what angle Y is. We don't know what angle H is. But we can go ahead and do some math to figure out knowing how triangles work. In other words, we can find out this angle by taking 180, right? Because all three angles in a triangle have to add up to 180 degrees, and then subtracting what we know. We know that this angle is 61. We know that this angle is 90. Okay, if you run that through your calculator, if you do it by hand, you'll see that the remaining value is 29 degrees. Okay, and it's not looking good for us. Okay, we have a 90 degree here. We have a 34 that doesn't match up with the 61 or the 29. All right, let's double check this one just to be on the safe side. All right, same thing. We know that all three angles here should add up to 180 degrees. We're going to subtract what we know. We know that it has 90 degrees here. We know that it has 34 degrees here. Okay, if you run that through your calculator or do it by hand, you'll see that it ends up being 56 degrees. Okay, so according to angle, we need at least two angles that are congruent. In this case, we only have one angle that's congruent, right? 61 doesn't match up with 56 or 34. 29 doesn't match up with 56 or 34. The only one is 90, and just one angle alone is not going to be enough to prove using angle similarity. All right, so in this case, this is not similar. Okay, it's not even a case of that we don't have enough information. We can straight up say this is not similar by any means. Right? It does not meet the definition of similarity, so these two triangles simply just are not similar to each other. All right, one last example here. There we go. Okay, same thing, we're going to determine which one of the three postulates we're going to use to show that these two triangles are similar. Okay, they might not be. We don't know. That's what we're going to figure out. Okay, so start at angle. Okay, for angle to work, we need to know at least two of the angles to show similarity. You can see here we don't have any of the angles labeled, so for sure we can't use the angle postulate. Okay, side, we need to know three of the sides here and all three sides here. If you notice, all three sides are labeled on both triangles, so more than likely it's going to be this one. But let's just double check one last postulate. Side angle side has to have at least two sides. Okay, we have three here, we have three here, that's at least two, and at least one angle. Notice again, we don't have anything determining between these two pictures if any of these angles are congruent to each other, or even what the angles are, the values of the angles, we don't know. So it's not going to be that one either, right? More than likely it's going to be SSS, side. Now, in order to check for similarity though, we have to prove that the first triangle is proportional to the second triangle using the sides. Okay, this is easy. Since we're using three sides, we're going to have three fractions, three ratios. Okay, all three of these ratios have to be proportional to each other. In other words, they have to be equal to each other, and we can easily check that. So I'm going to assign the bigger triangle to the top values, the numerators of our fractions, and the smaller triangle to the denominator values of our fraction. Okay, how am I going to write them out? Just let the numbers guide you. Okay, let the numbers guide you. You're going to go from least to greatest. So the smallest value here is 35. Okay, sorry, I was focusing on that 42. So 35 is the smallest value. Then we have 42, 42. Okay, so 42 here, 42 here. Now it's going from least to greatest. Okay, 35 is smaller than 42. So sorry about that. Okay, going to the smaller one. Again, pick from least to greatest. The least value is going to be 25. That's going to go first. 25. And then we have 30, 30. 30, 30. Okay, notice that 42 over 30 is automatically equal to 42 over 30. So we don't even have to test this last one. We're simply going to test these two fractions. If these two fractions are proportional to each other, if they're equal to each other. Okay, if you can't see it right off the back, use the calculator. There we go. Okay, so again, we're not using NSOLVE. We're just checking to see if two fractions are similar to each other. All right, our two fractions are 35 over 25. And our second fraction is 42 over 30. 42 over 30. Okay. If they are proportional, that means that they're equal to each other. That is true. Okay. So this fraction is equal to this fraction, and by default, since these two fractions just happen to be the same, these two are also equal to each other. So I don't know where that line came from. Oh, I can't erase it, but just bear with me there. Okay, so these are proportional, so the SSS similarity postulate does hold for this example, and you're good to go. Okay, so that's going to be the answer for this problem. All right, so you saw an example with SAS, right? You saw an example with AA. In fact, there was two of them. Oops. There's A. There's A. You saw an example where they don't have similarity. Okay. And then you saw an example with SSS similarity. All right. That's basically how your assignment's going to be. All right. Let's see. Anything else? Yep. So you'll have 10 problems. They're multiple choice. And again, you're just determining which postulate you're going to use to prove the similarity between the two triangles. Okay. You won't be using similarity statements this week, so you won't have to be trying to do the three letters as similar to the other three letters of the triangle. You don't have to worry about that. It's just going to be picking the postulate. All right, guys. So again, if you're watching this on Monday, happy Star Wars Day. Okay. Watch yourself some Star Wars. I don't have a wrestling shirt today because I wanted to wear this for you guys, being that it's May the 4th. May the 4th be with you. All right. Take care, guys. Have a good week. If you have questions, come to class, okay? Come to our video conference if you have questions, even if you want to just stop by and say hi. All right? Take care, everybody. Beautiful people of YouTube, beautiful students of Burgess High School. Have a good one, guys. Bye.